The sine rule is used generally for triangles which don't have a right angle in them. It can be used for any triangle really, but if it's got a right angle then use sine, cosine, tan and the rules of SOHCAHTOA. So the sine rule then, let's see how it works. The sides of any triangle conventionally are labelled with small letters and the angles with large letters, and conventionally the angle A is placed directly opposite the side A, and B against B and C against C. So that's worth bearing in mind. And the sine rule states that the side A divided by the sine of angle A divided by the sine of A, equals B divided by the sine of B, and equals C divided by the sine of C. So what it's really saying is any side divided by the sine of the opposite angle is always the same. Doesn't matter which one you take. So let's do an example and see how it works. We'll call that 80 degrees. This one 30. This side 15. And we call that A. And if you look at it, we've got what corresponds to B, the angle B in the side B, there and there, and we've got the angle A and the side A. So you can see we don't really need this section here, C and sine C, and we can use the bits we know to find A using the sine rule. So let's put everything in we know. A over the sine of 30 degrees, which corresponds to A, equals our B, which is 15, over the sine of 80 degrees. And we need to move this around a bit. Now if we multiply both sides by sine 30 degrees, that would disappear from this side, it would cancel out, but what we do to one side we must do to the other. So that becomes A equals 15 divided by sine 80 degrees times by sine 30 degrees. And now we need the calculator to work it out. (15) divided by the sine of 80, and we're going to need to close a bracket there, times by the sine of 30 equals, I'll just read that off a minute, and I'll do it to 3 decimal places. A equals 7.616 to 3dp, decimal places, and that's how that works. I'll do a couple more examples. So in this example we've got this angle and that side, and this angle, and we don't know that side. Well, if we look at this side corresponds to the A and the angle A, and that would correspond to angle C. So we need this portion and this portion. So we just miss out this bit here. They're both equal. So put in everything we know. So the A bit is 20 over sine 70 degrees equals the C over sine 50 degrees. And just like before, to get this C on its own, we've got to multiply both sides by sine 50, so that bit will cancel. So we're left with 20 over sine 70 degrees times by sine 50 degrees, and that equals C. So again, we need the calculator. (20) divided by the sine of 70. And the reason I closed the bracket there is because with this calculator, if I didn't, it would put the sine 50 inside the sine 70, which we don't want. So then times it by the sine of 50. And the question is asking us to put it to 2 decimal places, 16.30. C equals 16.30. Done. And I'll do one final example. Well, in this example, we've got something different. We've got to this time find an angle to 2 decimal places. And if we look at what we've got the A, side A 10. We've got side B is 12. And we need to find angle B. We've also got angle A. So we put in the bits we know. So that's going to be A over sine A, which is the 10, over the sine 45 degrees. And that equals 12 over the sine of B, which is the bit we want to find, or we want to find B really, but first we find sine B. So now we're going to have to move things around. Now I'm going to try and do it all in one go, but I'll explain it all. To get this sine B, we don't want to be left with 1 over sine B by moving that 12. We want to get the sine B over to that side, and on the top we want to move this lot this side. Now if you look at that, sine 45 degrees is dividing, so we times both sides by sine 45, which will bring it over here, timesing it. The 10 is above the sine 45, so we divide by 10, we'll bring it this side. And if we multiply everything by sine B, that will move the sine B up there. So see if you can see it all. Here we go. Sine B equals 12 over 10, because we divided both sides by 10, and we times it by sine 45. Okay, I'll put all that in the calculator. So 12 divided by 10, well that's going to be 1.2, isn't it? So 0.2 times the sine of 45. That gives us that. Now it's showing it in third form, so I'll just do SD, which changes it to decimals. And I'm not even going to put that down because that's the sine. So we want the B, which is going to be sine to the -1 of whatever the answer is. So I'm just going to put answer there. I'll show you that's done. So get sine to the -1. We now go shift sine to the -1, and then we press the answer key there, which brings up the previous answer, and then equals, that gives us it. So B equals 58.05 degrees, and that's our answer. Done. So that's the sine rule. There's a few good examples there. Give it a bit of practice, see how you get on with it. Okay, the only other rule you use when it's not right angled triangles is the cosine rule, so it may be worth watching the video I've made of that one. Okay.